Greetings, and welcome to our presentation on exploring machine learning algorithms for malware detection. My name is Kenneth Warren Cruz, along with Adel F. Del Valle Perez and Alberto I. Cruz Solomon. First of all, we want to thank MIT Lincoln Laboratory for sponsoring this project. During this presentation, we are going to talk about the project background, the introduction, the project objectives, including the methodology and the expected outcomes and impact, and finally, the deliverables. A little background of our project is that we initiated outside the IAP cycle, so we're going to extend our project until May 2022. Our main objective is to use machine learning techniques for the application of malware detection. Malware is developed by cyber criminals for disrupting, damaging, or gaining unauthorized access to computer systems. For us, it is very imperative to build and develop efficient and robust malware detection tools to defend systems before any attack or event. We will develop a machine learning or deep learning algorithm for these situations, but first, we will assess state-of-the-art to learn basic cybersecurity concepts. Later, we will familiarize ourselves with malware detection techniques with machine learning and deep learning to later deliver a malware detection algorithm that can compete or enhance what is today's detection concepts. Later on, we're going to talk about the introduction, so I'm going to pass you with Alberto.
So, the end goal of this project is to develop a system to detect unwanted or malicious software. This is due to the fact that criminal organizations and cyber attackers develop malware that actively avoids detection by constantly changing the program's appearance while keeping its functionality mostly intact. This project is not new. It's actually based on the efforts of past authors of malware detection systems that have attempted to address this problem by using different detection approaches, which include signature-based methods and behavioral-based methods. Both of these consist of inserting the code into virtual environments or sandboxes to securely run the affected code and observe if it sends signals outside the scope of its functions or if it behaves differently. There are three main objectives. Provide team members exposure to the cybersecurity field by assessing the state-of-the-art for malware detection, go through the experience of researching and understanding which features were already extracted by others of the given dataset, using supervised machine learning algorithms for malware detection in both Android and Windows operating systems, but it's not limited to Android and Windows, and it's not only supervised method of machine learning algorithms.
Thank you, Alberto. Now we follow on to methodology. We start with the datasets as we have targets in Internet of Things traffic, Windows, OS, and Linux POSIX systems, and binary dynamic libraries. For each dataset, we're going to be developing a machine learning pipeline that it consists of a data exploratory analysis, which is the critical process of investigating underlying patterns on the data to spot outliers, test hypotheses, find correlations between variables, among other steps. And continuing with data pre-processing. What is data pre-processing? It is the steps of cleaning the data, removing, filling missing values, and transforming and or encoding the data to state machine learning algorithms can process it. Following to model evaluation, that it consists of choosing a set of models within the assigned task to evaluate how they perform on the same dataset. After we perform model evaluation, it, it proceeds with tuning, that is essentially selecting the best parameters for an algorithm to optimize its performance. Once we finish the tuning, we go to training, where the algorithms learn from the training dataset and try to fit the underlying function of the data. After that, the model is evaluated on data it hasn't seen before. It called the test data set. The performance measures are evaluated as accuracy, sensitivity, specificity, and so on. Now we go to the next. We continue with the algorithms that are being considered. In this case scenario, we start with unsupervised learning, where it consists of unlabeled data and trying to find clusters of groups between the instances. We follow with supervised learning, where the data is labeled, therefore we have a response variable. Other optional algorithms are reinforcement learning, deep learning, and deep reinforcement learning. Expected outcomes and impact. The final outcome of this project is a report describing the different supervised machine learning algorithms used for the detection of malware from the given dataset. We, as members of the research, will be challenged to enhance our skills in numbers of areas including cybersecurity, machine learning, data analysis, and deep learning.
Finally, we have our deliverables. First, we're going to do an assessment of the state of the art, which we started in March, and then we'll end in during this month. For in August, we're going to continue with the dataset curation until September, when we're going to start the implementation of malware detection algorithms. And in April and May, we're going to do the final report, when we're going to present to you our results and see how the algorithm process. Last off, we just want to say thank you for your attention and also for your interest in our project. Please let us know if you have any doubts, any questions, or you want to just interact with us according to any topic that we mentioned during this presentation. Have a great day and thank you for your attention.